Okay, welcome to part 2 of lesson 1.5 on solving linear word problems. This is the example for mixture questions. There's 2 examples. We're going to do the first one, and I'm going to leave the second one for you to try on your own after the video. And of course, you can check your answer on the course website. So in example 1, it says Jeff has a bottle of 5% acetic acid and a bottle of 10% acetic acid. How much of each should he use to make 250 milliliters of 8% acetic acid? Well, I've included this little table here to kind of help us organize our information so we can build our equations. But first, let's think about our variables. It says how much of each should he use? So it's asking how much of the 5% and how much of the 10%. So those are our variables. Those are the things we don't know. So I'm going to use A and B. I'm going to call the first acid A and the second acid B. So as a let statement, I might say let A be the amount of 5% acid. And let B be the amount of 10% acid. So what do we know? Well, we know we're making a mixture of the two, and we're using how much of each should he use to make 250 milliliters. So that means we're putting some A, some B to make 250 milliliters. And that actually leads us to build our first equation. A plus B is going to equal 250 milliliters total. So we're adding some A, some B to make 250. The second part of the equation involves the percentages. First is the amount, the second is the percentages. So 5% acid. That means we're really only getting 5% of this amount of liquid is the acid. So the acid equation involves the percentages. 5% is a decimal 0.05, so we have 0.05 A, which means 5% of A is actually acid. And we're going to add that to 10% of B is actual acid, and together we're going to make, well, 250 milliliters, but it's not all acid. Only 8% of it is acid. So that's 8%, 0.08, of 250. So if you look, this question's actually kind of nice because it's really one equation and then we tweak it with the percentages. So we've got 5%, 10% to make 8%. If the first equation is just as simple as A plus B equals 250, some A, some B to make 250, the second equation is the exact same, just with the percentages. 5% A, 10% B, 8% of our total. And that's how we build our 2 equations. One of these we can actually figure out what 8% of 250. If we do that in our calculator, we get, let's see, 0.08 times 250, should be about 20. That's 20. And we can use these to build equations. Well, what are the 2 equations? Well, here we go. We got A plus B equals 250, and our percent equations are 0.05 A plus 0.1 B equals 20. Those are our 2 equations. And now we could do substitution or elimination. Up to you. Let's go with substitution. So I'm going to rearrange equation 1. Let's call that equation 1, equation 2. Rearrange equation 1. I'm going to make it say A equals. So A equals, we have 250, and I'm going to bring the B over, subtract B. And now I'm going to sub 1 into 2. Equation 2 is 0.05A plus 0.1B equals 20. And equation 1 says that A is 250 minus B. So instead of A, we write 250 minus B. And this is the first time all year we're going to work with decimals. So now we've got a number in front of the bracket. We're going to distribute and multiply. Calculator here. 0.05 times 250 is 12.5 minus 0.05b plus 0.1b equals 20. I'm going to collect my like terms, so I'm going to move the 12 to the other side. 20 minus 12.5, and we've got negative 0.05b plus 0.1b. We put our like terms together, we get 7.5 on this side, and on this side we get 0.05b. Last step, divide away the 0.05. We end up with B equals 150. And we're talking milliliters, so that's 150 milliliters. How do we find A? Well, we sub B equals 150 into one of our equations. Let's use equation 1. Equation 1 is A equals 250 minus B. B is 150. If we subtract, we get 100. So we've got 100 of A and 150 of B. So we can write a therefore statement now. Therefore, Jeff should use 100 milliliters of 5% and 150 milliliters of 10%. There we have it, mixture question. So the second example that I want you to try on your own is very similar to the first one, except instead of about acid, it's about milk and cream. So it's saying how much of 3% milk needs to be mixed with 15% cream to get 6% cream. And it's very similar to the exact, to the question above. You're going to set up your mixture question with your totals. So if you're using A and B again, or if you're using M and C because it's milk and cream, you've got milk plus cream equals the total amount, 20 liters, and then make your percentage examples, and then you've got your two equations, and you can do substitution or elimination. I'll leave that example for you. If you want to try it now, you can check your answer on the course website. And that's it for Type 2 mixture questions. Be sure to watch the third and last video of the unit where we look at speed and distance word problems. Thanks for watching, and I'll see you next time.